How cold can a star get? It sounds like a trick question because stars are supposed to be blazing hot, roaring furnaces of plasma that melt anything daring to get close. But here's the hook for the first 10 seconds. Some stars are so cold that if a hand could touch them, they would feel barely warmer than a summer evening. Stay with this video until the end because the answer is stranger, more surprising, and far more fascinating than it seems at first glance. Most people imagine stars as identical glowing spheres, all burning with the same furious intensity. In reality, stars come in an enormous range of temperatures, colors, and stages of life. Some are bright blue giants that scorch space around them. Others are tiny fading objects that barely glow at all. And somewhere in that spectrum lies the coldest category of stars ever discovered. Objects so faint and so cool that they challenge the very definition of what a star is. To understand how cold a star can become, it helps to start with what makes a star hot in the first place. A star's heat comes from nuclear fusion, the process of squeezing hydrogen atoms together until they merge and release energy. As long as fusion continues, a star shines. When fusion slows down or stops, the star begins to cool. But cooling in space is slow, and stars are massive, so even a dying star can remain warm for billions of years. That's why discovering extremely cold stars is so surprising. It means something unusual is happening. The coldest stars known today belong to a class called brown dwarfs. These objects sit in a strange middle ground between planets and stars. They are too small to sustain long-term nuclear fusion, yet too large to be considered planets. They glow faintly, not because they burn like normal stars, but because they retain leftover heat from their formation. Over time, they cool, dim, and fade. Some of them reach temperatures that barely exceed room temperature. Halfway through the video is a good moment to pause for a second. If this is interesting so far, consider liking the video, subscribing, and turning on the notification bell. It helps the channel grow and ensures future videos reach you the moment they're released. Now, back to the mystery. The coldest brown dwarfs discovered so far have temperatures around 250 to 300 Kelvin. That's roughly -22 plus 30 degrees Celsius. In other words, colder than a winter night in many countries. Imagine a star that could be approached without burning, a star that emits so little visible light that it appears almost invisible. These objects don't shine like the stars seen in the night sky. They glow faintly in infrared, like warm stones cooling after sunset. What makes this even more fascinating is how difficult these cold stars are to detect. They are so dim that telescopes must search for them using infrared sensors, scanning the sky for tiny patches of warmth rather than visible light. When one is found, it often looks more like a ghost than a star, a barely detectable whisper of heat drifting through space. The existence of such cold stars raises deeper questions. If a star can cool to the temperature of a freezer, what does that mean for the boundary between stars and planets? Could planets orbiting such objects experience conditions unlike anything seen around normal stars? Could chemistry behave differently in such environments? These questions are still being explored, and each discovery adds a new layer to the story. Another surprising detail is that these cold stars are not rare. Brown dwarfs may be scattered throughout the galaxy in enormous numbers, hiding in the darkness between brighter stars. Some astronomers believe they could be as common as normal stars, maybe even more common. If that's true, the galaxy might be filled with cold, faint objects that have gone unnoticed for most of human history, simply because they are so hard to see. As the video approaches the end, it's worth emphasizing that the coldest stars challenge the imagination. They show that the universe is not just filled with blazing suns, but also with quiet, fading embers. They remind us that stars are not static objects, but evolving entities that change dramatically over time. And they reveal that even something as familiar as a star can surprise us when we look closely enough. Before wrapping up, share in the comments what temperature you expected the coldest stars to have. Did you imagine something icy, something warm, or something completely different? Hearing different guesses often inspires new ideas for future videos. To close the video, remember to like, subscribe, and turn on the notification bell if this resonated. More videos are coming that explore cosmic mysteries, strange astronomical objects, and the hidden stories of the universe. How cold can a star get? Colder than almost anyone expects, and cold enough to reshape the way stars themselves are understood.